This is a key to the following worksheet. So on this worksheet, you want to find the distance and midpoint of the segment whose endpoints are listed. Now make sure you see the directions where it says show work for distance. So you're expected to find when you find the distance to show the work. And you're asked to use the distance formula. Okay, so let's look at number one. So number one, we have these 2 points. And first of all, let's find the distance. So we know that the distance between any 2 points, or the distance between 2 points in a coordinate plane, can be found by the distance formula. And the distance formula is the square root of. And basically, you're going to subtract the x coordinates from each other. And whatever that difference is, you're going to square that. And then you're going to add that to the difference between the y coordinates. And then once you find that difference, you're going to square that as well. Okay, so that's the distance formula. And the midpoint formula, so the midpoint formula is, remember that's a point, so you need to write this as a coordinate. And so the formula for midpoint between 2 points, the midpoint of a segment whose endpoints are 2 points, can be found by adding the x coordinates together, divide by 2, comma, and then the y coordinate of the midpoint can be found by adding the y coordinates together and dividing by 2. So divide by 2, just think of middle. So the middle, divide by 2, midpoint. Okay, so let's go ahead and find the distance. Now, many students, when they are using the distance formula or the midpoint formula, they tend to label these coordinates. So if we call this the first point and this the second point, then we'll call this x sub 1, y sub 1. So the x coordinate of the first point, y coordinate of the first point, and this will be x2, y sub 2. And then now it's just a matter of you taking all this information and substituting into the formula. So the distance equals the square root of, so this is your work. So you're going to say in parentheses x2, which is negative 3, subtract x1, which is a negative 1 squared, plus, and then do the same thing with the y coordinate. So negative 4 subtract 0. So negative 4 subtract 0, and that's being squared. So you have to show that. Then you have to also show at this point that you are simplifying what's inside the parentheses. So negative 3 subtract a negative 1 means negative 3 plus 1 squared, plus, and then over here that's negative 4 and then minus 0 is a negative 4 squared. Simplifying that further, I get the square root of negative 3 plus 1 is a negative 2 squared. So basically I'm squaring a negative 2 and I'm also squaring a negative 4. And then I know that when I square a negative 2, so square root of, when I square a negative 2, that's a negative 2 times a negative 2, which is a positive 4. And then a negative 4 squared is a negative 4 times a negative 4, which is a positive 16. And when I add 4 and 16 together, when I simplify that radicand, I get the square root of 20. And remember the directions does say simplify radicals if possible. So notice I can simplify the square root of 20 because the largest perfect square that goes into 20 is 4. So it becomes the square root of 4 times the square root of 5. 5 times 4 is 20. And the square root of 4, since 4 is a perfect square, the square root of 4 is 2. So you get 2 square root of 5. So that's the distance, and there's your work. Okay, so make sure you see show work for distance. Always follow directions. So this is 2 square root of 5. Now for the midpoint, so the midpoint, now I didn't ask you to find the work for midpoint because you could easily look at this and add those together and divide by 2. But here's what you do for the midpoint. So first of all, you would add the x coordinates together. Now the way I have it written is I have x2 plus x1. But you could say x1 plus x2 because addition is commutative. So it does not matter what order you add the x's. It does not matter in what order you add the y's. Okay? So negative 3 plus a negative 1, negative 3 plus a negative 1 divided by 2. So you add the x's together, add the x coordinates. For the y coordinate, you're going to add the y coordinates of the end points together. So negative 4 plus 0 divided by 2. But you got to simplify this So negative 3 plus a negative 1 is a negative 4 divided by 2, comma. Negative 4 plus 0 is also a negative 4 divided by 2. And then simplifying that, I get negative 4 divided by 2 is a negative 2. Negative 4 divided by 2 is a negative 2. So that point is the midpoint of the segment joining those 2 points. Okay? All right, so the midpoint will be negative 2, negative 2. All right, so work, answer. All right, for distance. Okay, number 2, we have this for number 2. So actually, yeah, number 2. So number 2, we have these 2 points, negative 2, 3, and we also have negative 7, 7. All right, very helpful for many students to label these coordinates. So x1, y1, x2, y2. All right, and so here's your work for distance. You're going to say distance equals the square root of. So remember, you're gonna subtract the x coordinates from each other. You're going to square it. You're going to subtract the y coordinates from each other, and you square it. So you're going to say subtract the x coordinates. You're going to say negative 7 subtract a negative 2. So this x subtract this x. Remember the operation subtraction, so you got to keep that in mind. Negative 7 subtract a negative 2 squared plus. And then you subtract the y coordinates. 7 subtract 3. 7 subtract 3 squared. All right? And so that's going to equal, and let's go ahead and simplify what's inside the first parentheses. Negative 7 subtract a negative 2 means negative 7 plus a positive 2. So you add the opposite. Negative 7 plus 2, but that's being squared. Plus, and then 7 subtract 3, I can simplify that. I know what 7 subtract 3 is. 7 subtract 3 is 4, so I'm going to square that. Equal, square root of. Negative 7 plus 2, that's a negative 5. So I'm squaring a negative 5, and I'm squaring a positive 4. Well, let's simplify the radicand. A negative 5 squared is a positive 25. A 4 squared is a positive 16. Simplifying the radicand, 25 plus 16. So 25 plus 16 is going to give you 41, right? So I get the square root of 41. Now 41, the only perfect square that goes into 41 is 1. So I cannot simplify the square root of 1. So the square root of 1, you're done with. Okay? So that's the answer for number 2. So number 2, you're going to say square root of 41. So notice, though, the work, you must show work. So this is your work. You must follow directions. Always read the directions. For the midpoint, you do the same thing. That's the easy part. You do the same thing as you did with the first one. So the midpoint, you're going to, so the midpoint, remember, is a point, so you got to write this as coordinates. So in this case, you add the x coordinates together. Again, since I'm adding, the order in which you add does not matter. The x's in the order in which you add the y's does not matter because I'm adding. Now, so negative 2 plus a negative 7. So those are my x coordinates. I'm going to divide by 2. And then we're going to add the y coordinates together, 3 plus 7. So remember, you're adding, not subtracting. And divide by 2. Okay, so simplifying the first fraction. The numerator, negative 2 plus a negative 7 is a negative 9 divided by 2. 7 plus 3 is 10 divided by 2. And you got to simplify if you can. You know you can simplify 10 halves. So the answer is negative 9 halves, comma, 5. So there's your midpoint. So the midpoint is in parentheses, negative 9 halves, comma, 5. Number 3. So this is number 3. So number 3, we have, all right, so let's see. We have negative 7, 1, and the other end point is negative 2, 5. So I want to find the distance between those 2 points. I want to find the distance of the segment that contains those points as end points. So let's label these x1, y1, x2, y2. So the distance equals the square root of, now remember you're finding distance, so you can subtract these coordinates. So negative 2 subtract a negative 7, so you subtract the x coordinates. Negative 2 subtract a negative 7 squared plus, and then do the same thing with the y coordinates. Y subtract 1. 5 subtract 1 squared equals, and let's do that here, equals the square root of, simplifying the parentheses here, negative 2 subtract negative 7 means negative 2 plus the opposite. So that's negative 2 plus 7 squared, plus, and then 5 subtract 1 is 4 squared, right? So that becomes the square root of, and then negative 2 plus 7 is 5. I'm squaring 5, and I'm also squaring 4, right? And then let's go ahead and square that 5. So so I get a square root of 5 squared is 25, 4 squared is 16, and in this case I also get the square root of 41. And we just saw that I cannot simplify the square root of 41. So number 3, you get the square root of 41. The midpoint is easy. You just, for the midpoint, you are just going to add the x coordinates together and divide by 2. So negative 7 plus this x coordinate, negative 2, just like this. Divide by 2, and then you're going to add the y coordinates, 1 plus 5, divide by 2. Simplifying that, negative 7 plus the negative 2 is a negative 9 halves, and then 1 plus 5 is 6. I get 6 halves. I can simplify 6 halves, so you're expected to do that. So you get negative 9 halves, comma, 3. So there's your midpoint. So that's the point in the middle of the segment joining those two end points, those 2 points. So negative 9 halves, comma, 3. All right, and then number 4, the last one, we have negative 2, negative 3, and the other point is 2, 5. So I want to find the distance between those 2 points, and I'll find the midpoint of the segment containing, or whose endpoints are those 2 points. So let's label these x1, y1, x2, y2. Okay, and so when I use the distance formula, I get distance equals the square root of, let's go ahead and subtract the x coordinates. So I have 2 subtract a negative 2, in parentheses squared, plus, and then 5 subtract a negative 3 squared. 5 subtract a negative 3. Simplifying this, I get the square root of 2 subtract a negative 2 means 2 plus 2, just like this, squared, plus, and then 5 subtract a negative 3 means 5 plus 3 squared, right? Equal the square root of. Okay, now simplifying those parentheses further, 2 plus 2 is 4, so I get the square root of 4 squared, plus 5 plus 3 is 8, so I get 8 squared, equal. And then the square root of 4 squared is 16. 8 squared is 64, right? And so 16 plus 64 will give you, what's that? That's going to be 80. So I get the square root of 80. Now there is a perfect, there's several perfect squares that go to 80, like 1, 4, but the largest is 16. So I'm going to write this as the square root of 16 times the square root of, 5? And so the square root of 16 is 4, so you get 4 square root of 5. So that's the answer, because it did say to simplify the radical. All right, so that is the distance. That is the distance between those 2 points. So 4 square root of 5. And then the midpoint, that's the easy one. So for midpoint, you're going to add the x coordinates together. So remember, midpoint, you add and then divide by 2. Add, divide by 2. So negative 2 plus 2, divide by 2, comma, and then negative 3 plus 5, divide by 2. All right, so notice I wrote this as an ordered pair. So negative 2 plus 2 is 0, so I get 0 divided by 2. Negative 3 plus 5 is 2, so you get 2 divided by 2. And then you have to write 0 divided by 2 is 0. You have to know that's 0. And you also have to know that 2 divided by 2 is 1. So that's the answer you need to give. So in number 4, the midpoint has the coordinates 0, 1. Okay? So that is the key to the worksheet on finding distance and midpoint.